Hello everyone and welcome back in our class of Foundation Engineering. Today we will try to finish this chapter number 2, the in situ soil testing. And maybe from next time, we will start shallow foundation design. Okay, so I think we have covered all these from 1 to 11. Today, we will talk about the water table observation and how to prepare the boring logs and how to make a report, subsoil exploration report, because after exploration, you have to make the report. Roughly, this is what we are going to talk about today. Not too long, it's very short. Okay. So, and it will be the end of this chapter. So let's go with the first point of this today's video, how to observe water table. I think from the CPTU, we can already obtain water table. We can obtain information on water table. And there is also type of piezometer because the device, the CPTU also is using this piezo cone. Okay, CPTU piezo cone. Same, the Kazakhstan type piezometer. There are several types, and it will tell us this device helps to know the water table, the water level in the ground. Okay, so if there is water table near the ground surface, it will impact the stability on the foundation for sure. Okay, so we better know the level of water table. Where is the water table located? So that we can predict the influence on the foundation, on the capacity, bearing capacity. Okay, so it impact the foundation load bearing capacity and also settlement and many other performance factor. Okay, so since water level is sometime changing, it going sometime up and down depending on the season. Some country have like rainy season and dry season. Depending on the season, the water level is not same. So in that case, it's better to know the highest and the lowest possible water level in the ground for your project. It's very important in that case. Okay, if the water is found in borehole during exploration, it should be documented. So during the exploration, if you find water, you need to note it somewhere. You need to write it in the report, and the report is what we are going to talk at the end of this video. Okay, in soil with high hydraulic conductivity, the permeability is high. Water level typically stabilizes within like 24 hours after boring is complete. It means if you are dealing with ground like sand or gravel, the hydraulic conductivity is high. So if you dig, the water level can be stabilized very easily. So the depth of water level can be measured by lowering a chain of tape into the borehole. In that case, like in your borehole, this is like visible. Sometimes you can see even the water. Okay, this is in case you dig your borehole and you can see the water, or there is water, you can measure directly, lowering something like that. Otherwise, we can use this kind of thing. Okay. So high permeable layer, if we are dealing with this kind of layer, soil that are highly permeable, borehole water level may take weeks to stabilize. Okay. So you cannot dig and immediately take the water level to say, this is the water level. You can, sometimes it take weeks before you know the stable water level. Okay. For accurate measurement, we need piezometer. This is piezometer, the Casagrande type 1. Okay. It consists of porous stone and preferred pipe, which is attached at the standpipe, and it helps us to measure to obtain the water level. You can see here groundwater level and piezometer water level. So we have this kind of device that help to enable predict and monitoring until the water level stabilize. So we can check from time to time, because sometimes, as it said here, sometimes it takes weeks before the water level be stable. But anyway, let's go now for preparing, how to prepare boring logs. So detailed information from each borehole is com completed in compiled in graphical bore logs. Okay, so when you are digging, as the drilling progress, the driller typically record the following in the bore in the logs. You write, sometimes you draw, you make some drawing to notify at this depth we have this type of soil, this depth you have this type of soil. Okay, first you need to write the name and address of the drilling company, the name of people who are doing the work, driller's name, job description, and number, type, and location of boring. Because if you are doing many, you need to know each of them, the exact location where the work was done, and the date, the subsurface stratification. This is what I was saying. You need to write at this depth. You have this, for example, clay. Here you have silt, you have sand, you have gravel, different type of sand sometimes. Okay, so subsurface stratification, which can be obtained by visual observation of the soil, because when you are digging, you are making the hole, you are bringing out soil, you can observe at this depth, the soil is changing, becoming this kind of thing. Okay, so brought the soil you are bringing out by the auger, or like a spirit spoon sampler for SPT, and also the Shelby tubes. We have seen different type of sampling, different method of sampling. You also need to note, write elevation of water table and date observe observe. As we have seen previously, water table can take few days or few weeks before to be stable. So you need to note every day the date of observation of water table. Okay? So these are like among many other like parameters or things you need to write down. Okay. You need also, in case of standard penetration, resistance, and depths of this one. you can do that. Okay, you can record the standard penetration resistance, because if you are doing SPT, you have to record it immediately when you cannot leave without recording that. And the number, type, and depth of soil sample collected. Okay, for example, for different type of soil, you can collect. For one type of soil, you can collect several types soil sample. Okay, and in case of rock coring, because we have seen previously in the previous video that there are some sites we detect presence of rock, and we need in that case to take some rock sample. So in that case, the type of core barrel used, and for each run, and the actual length of coring, the length of core recovery, and the RQD need to be noted, need to be written in the report, the boring log. Okay, the rock quality designation. So once laboratory tests are completed, the geotechnical engineer will compile finished borehole log, because to complete the borehole log, we need some time to write, for example, for each soil stratification, what are the soil parameter, what are the soil characteristics. Okay, so that's why we need some time to wait for the lab report to complete this borehole. Okay, okay. So lab test and field also, drill out field log and lab test. We put them together. Okay, this is an example of typical boring log. There are many types. Okay, because here we can see soil description. Light brown clay, for example, this is just field. So in some case, people just try to draw it, make like to make a difference, so that if you see directly, you can see the different type of layer. Okay, here we have silty sand. Okay, at this depth, you can see the depth here. Okay, at the surface, you have just feel light brown clay. Okay, maybe from here 1 meter, 2 meter, because depth here is in meter. Then you have here the soil sample type and number, the SPT N value N60, water content. You can see that sometimes this water content you need to get the lab report, and also some Atterberg limit, liquid limit, and plastic limit, plastic index. Okay, this kind of information sometimes you need to go to wait for the lab report. But as said, here you need to write like the name of the project, location, okay, date, the boring number, where is the location, the number, which number is it, number 3, the type of like auger, okay, the ground, and boring and elevation, some information you don't need. So this is typical one. There are many types, and we can see here water level here. Can show the water level is around 3.5 meter depth. Okay. At at the end here we have sand with some gravel. Okay. SP a poorly graded sand. Okay, and the end is at 8 meter. The boring is at 8 meter. Okay, this is just example. You can do different. There are different models, but if you are in charge of uh, the site investigation, this kind of thing is very important. You should take care of. Okay. Next, so soil classification appear in left here. That's what we said already. Based on the unified soil classification system, there are many system. Okay, many type of classification. The unified one is used here. Let's go for the subsoil exploration report. How do you report the exploration? Because after completing everything, you have to report. You collect some soil sample, rock sample, okay? And these are sometimes visually inspected and subjected to necessary laboratory tests, okay? Basic soil testing, like liquid limit, plastic limit, or plasticity index, granulometry, this kind of thing. So once all data are complete and compiled, the soil exploration report is prepared, okay? That will help for both design and future construction reference, because if someone else want to build near the place where you did this report can help them also, okay? So although the report's structure may vary depending on the project and the compiler, it should consistently include the following items. It means the report depends on who is doing it and like which company and how and what type of project we are dealing on. But roughly each report should have this kind of item. One is it should describe the scope of the investigation. Number two, describe the proposed structure for which the subsoil exploration has been conducted. Number three, describe like the location of the site, including any structure nearby, like drainage condition, the nature of vegetation, and the site and surrounding, and any other feature that make the site unique. You have also to talk about all surrounding, all the items around. I think we have to talk about this, the beginning of this chapter. Okay. You have to describe also the geological setting of the site. You have to give detail of field exploration. Okay, that is the number of boring, the depth of boring, the type of boring involved, and any other thing that can help for the field exploration. You have also to give a general description of subsoil condition as determined from soil specimen, okay, and from related laboratory tests, standard penetration resistance, cone penetration resistance, and so on. You have to give also description of water table condition, and you have to give some recommendation regarding the foundation, including the type of foundation that you are recommending based on this field exploration. You need to propose type of foundation that is suitable for this building, the project, and you have to propose then allowable bearing capacity pressure and any specific construction procedure that may be needed. Okay, and alternative design procedure should also be discussed in the portion of the report. And at the end, you have to give a conclusion and limitation of the investigation, because sometimes you cannot do everything. There are some limits. Okay, maybe you couldn't do this, you couldn't do that. You have to give some detail and tell people what they should be careful of. Okay, so the following graphical presentation should be attached to the report. Just some graphic, some drawing that you should need, you should add to the report. Okay, the map, the location of the site, you should add it. Plan view of location of the boring with respect to the proposed structure and those nearby. Boring logs, you should, like boring logs, you have seen already the drawings. You have to put them, include them, and lab test results and other special graphical presentation. Okay, exploration report should be planned, well planned and documented, because it will help to answer a lot of questions and solve the problem, a lot of problem related to foundation that may rise later during the design and construction. Okay, it means it like a document that you may consult anytime. You check in the report during the construction and actually after construction also, because it may help for any other construction nearby, near that project. So it's important to keep it. So that will be the end of this chapter. Thank you very much for your time, and we will continue with a new chapter next time. Thank you very much for it.